Okay, z-score. When we have a normal distribution, a z-score tells you how many standard deviation a particular data item is away from the mean value. Okay, it's higher or lower than the mean value. Okay, so you have a particular data item. Okay, z-score tells you how many standard deviation that particular data item is away from the mean value. For example, let's say the mean value is 70, standard deviation is 4, right? That's the example of, male adult heights that we have covered before. So here's the distribution as you see this graph, right? So the z-score for data item 78 is 2. So mean value is 70, so 78 is 2 standard deviations away from 70. So the z-score for the data item 78 is 2. Okay, so look at, for example, 58. So mean value is 70, 1, 2, 3. So 58 is 3 standard deviations lower than the mean value. So the z-score for 58, for the data item 58, is negative 3. Negative means that it's lower than it. We have a value that is lower than the mean value, right? And 3 means it's 3 standard deviations away from the mean value. So based on this definition, then here is the equation that we have for the z-score, right? So data item minus the mean value. We want to see how far a data item is from the mean value, and that distance, how many standard deviation is, right? So our standard deviation, okay, so z-score is your data item minus mean value over the standard deviation. So the score tells you how many standard deviation a particular data item is above or below the mean value. Okay, when we have a positive z-score, it means that the data item has a value that is higher than the mean value, right? It's above the mean value. And when we have a negative z-score, it means that we have a data item that has a value lower than the mean value. It means the data item is located, is below the mean value, right? Okay. Let's look at this example. The mean weight of newborn infants is 7 pounds. Okay, so the mean value is 7 and the standard deviation is 0.8 pounds. Standard deviation is 0.8 pounds. The weight of newborn infants are normally distributed. Find the z-score for the weight of 9, 7, and 6 pounds. Okay, z-score is data item minus the mean value over standard deviation. So for part A, your data item, so z-score for 9 pounds is data item, which is 9, minus mean value, which is 7, over standard deviation, which is 0.8. Okay, use your calculator. 9 minus 7, okay, is 2 over 0.8, 2.5. 2.5, and it's positive, right? Yeah, 9 is a value that is above the mean value, which is 7, right? Part B, it's a 7 pounds. Okay, z-score for 7 pounds. It's your data item, which is 7, minus mean value, which is 7, over standard deviation 0.8. 7 minus 7 is 0. 0 over 0.8 is 0. So the z-score of the mean value is 0. And part C, 6 pounds. Okay, z-score for 6 pounds is your data item 6 minus mean value 7 over standard deviation 0.8. Okay, 6 minus 7 is negative 1 over 0.8. Use your calculator. Okay, so it's negative 1.25. As you see, we have a negative value because 6 is below the mean value, right? So here is the z-score, 2.50 and negative 1.25. Okay, comparing the z-scores. Well, let's say we have the scores on two different tests. okay, in relation to the mean on each test. We can use the z-score to see which score is better in comparison with the class score, okay? So in relation to the mean on each test, okay? So the item that has a higher, greater z-score, it means that the student did better on that test, okay, in comparison with the whole class, right? So, for example, we have a student that scores 70 on an arithmetic test and 66 on a vocabulary test. The scores for both tests are normally distributed. Arithmetic test has a mean value of 60, standard deviation 20, and the vocabulary test has a mean value of 60, standard deviation of 2. On which test does the student have a better score in comparison actually with the whole class in relation to the mean value, okay? So we find the z-score for each one, okay? Z-score for 70 for the arithmetic, okay? So here is the arithmetic test for the, well, the score is 70, so arithmetic test has a mean value of 60, standard deviation 20. So the z-score is half. So for the vocabulary, student got 66. The mean value is 60, standard deviation is 2, so z-score is 3. So in comparison with a class, the mean value of the class, student did better, okay, in relation to the mean value, okay? Comparison with a class, well, the vocabulary has a higher z-score, student did better, right, on that test in comparison with the whole class, okay? Here we go. Let's go back to the IQ example. We said that IQ scores, are normally distributed. The mean value is 100. So mean value is 100 and standard deviation is 16. Standard deviation is 16. What is the IQ corresponding to a z-score of negative 1.5? Okay, so I know that z-score is data item minus mean value over standard deviation. So here we want to find the data item. It says that the z-score is negative 1.5. I just plug in the values. The item we want to find is, so it's the unknown. So I call that x, okay? Minus mean value is 100. Standard deviation is 16. Guys, whenever you want to find an unknown, you need to isolate it by itself on one side of the equation. So you need to get rid of the numbers around the unknown, okay? So here I have 100, I have 60, I'm gonna get rid of them. First, I get rid of 16. I multiply both sides of the equation by 16. So on the left side, I have 16 times negative 1.5. On the right side, I have x minus 100 over 16. I multiply that by 16. On the right side, 16 and 16 cancel each other. That's exactly what I want. And on the left side, well, I have 16 times negative 1.5. Okay, I'm going to use the calculator. 16 times 1.5 and the answer is negative, so it's negative 24. Negative 24 is equal to x minus 100. I want to find x, so I add 100, positive 100 to both sides. So x is equal to 100 minus 24. Okay, so 100 minus 24 is 76, so x is equal to 76. You can follow any methodology to find x, okay? This is my method. As long as you have 76, that's great, okay? So I found it is 76. Here we go. Yeah, I used two methods here to find 76. Here we go. IQ scores are normally distributed. Mean value is 100. Mean value is 100. And standard deviation is 16. Okay, now part B of this question. It says Mensa is a group of people with high IQs whose members have z-scores of 2.05 or even greater. Okay, what is the IQ corresponding to a z-score of 2.05? So we have the z-score is 2.05. We want to find out the item corresponding to this z-score. It's just very similar to what we solved, okay, right now, just a few minutes before. Okay, go ahead. I give you around 1 minute to answer this question. Okay, go ahead. If you need more time, please pause the video. Okay, I know that z-score is data item minus mean value over standard deviation. Okay, so z-score here is 2.05 is equal to the data item is the unknown. So I call that x minus mean value is 100 over standard deviation 16. Again, x is your unknown. To find it, you need to keep it by itself on one side of the equation. So I need to get rid of the numbers around it. So I multiply both sides of the equation by 16. On the left side, I have 16 times 2.05. On the right side, x minus 100 over 16. I multiply that by 16. On the right side, 16 and 16 cancel each other. Great. So on the left side, let's see what we get. 16 times 2.05 is 32.8. So on the left side, I have 32.8. On the right side, I have x minus 100. To find x, I add 100 to both sides, right? So x is 100 plus 32.8, so it's 132.8. So that's a very high IQ actually. Okay, so you can use any methodology to find x as long as 132.8. That's great. So I'm offering two methods here. Both gave me 132.8. Here we go. We talk about z-score. Now I want to talk about the percentiles, so I give you a break. I'll be back.